These are the 5.32 notes, and we're going to continue working with exponential functions here. So we're going to be introduced to the idea of exponential equations right now. And we're going to get a little bit more intense with these exponential equations, especially once we start learning some logarithms in order to reverse our exponential equations. But we're going to start with the very basic stuff. So an exponential equation is an equation that involves terms in the form of a to the x power. Again, a has to be greater than 0, so you have to be working with a positive number. And a can't be equal to 1, because if we had a is equal to 1, 1 to any power is just 1. That's the same thing as f of x is equal to 1. We often refer to these as exponential equations, and they're going to be able to be solved by this premise. If a to the u is equal to a to the v, then u is equal to v. Now, this might look weird to you. Why is u equal to v here? Well, this is the same thing as saying, like, all right, let's say that I said that 2x was equal to 2 to the 4th power. Oh, this is really easy for us to say, all right, if 2 to the x power is equal to 2 to the 4th power, very clearly, x just has to be equal to 4. This gets a little bit more intense for things like if I say 2 to the x is equal to 16, I have to recognize that 2 to the x is equal to 2 to the 4th power, because 2 to the 4th is equal to 16. And again, I'm able to say that x is equal to 4. So that's what this premise is saying, that if I have the same base, if I have a base of 2, if I have a base of 2, and I'm setting them equal to each other, and one of my exponents is a variable and the other exponent is known, well, then I can use that exponent that has a variable, set it equal to my known exponent, and I can figure out what the value of that variable is. So we're going to solve an exponential equation down here. Solve 3 to the x plus 1 power is equal to 81. All right, so first what I have to do is figure out, is 81, I'm given a hint here, and my hint is that I should be looking for something that is a base of 3. Because here I've got 3 to the x plus 1, so that means that I'm going to be looking for 3 to some power. I need to have that same base of 3. 3 is a prime number. I'm not going to be able to break that 3 down anymore, so somehow I've got to form 81 into a base of 3. Well, 3 to the 4th power is equal to 81. How did I know that? I knew that because I've been doing this for a very, very long time. I've been working on this consistently. If this is something that you struggle with, if you can't look at 81 and know that it's just 3 to the 4th power, which is understandable. I don't think many people are just able to look at 81 and say, oh, that's clearly 3 times 3 times 3. You're given this hint here. Again, you have this hint that 3 is your base. And I keep writing it out because this is such a big hint. Since 3 is base, what I would do is I would go through and I would multiply 3 times 3 in my calculator. And we all know that 3 squared is 9. Most of us are also probably going to realize that 3 times 9 is 27. So now we can say definitively 3 cubed is equal to 27. Well, now I'm going to do 27 times 3. I'm going to plug this in on my calculator, and I'm going to see that when I plug in 27 times 3 on my calculator, I do the math in my head, that's equal to 81. So now I can definitively say that 3 to the 4th power is equal to 81. This is one of the hardest parts about solving the exponential equations you're going to get in your book, is that they give you a number and they're going to expect you to know what the base is and what power it's to. So on a no calculator section of a quiz or test, I'm going to give you numbers that I think should kind of be in your wheelhouse. They're going to be working. You should be able to figure out that like 5 cubed is 125. You should be able to know that 6 cubed is 216. You should be able to figure all of these values out, and we'll get better with it over time. It takes some time to get there. 7 cubed is 343. All these numbers are numbers that you might see. The more you work in the book, the better you're going to get at recognizing these, and the more time you spend doing math, the better you're going to get at recognizing them. Sometimes it's going to take a little bit of like brain power. You're going to have to sit and think and kind of use some hints. Other times it's going to come to you naturally, and that's okay. But now that I'm here, now that I'm at this 3 to the x plus 1 power is equal to 3 to the 4th, this is where it's easy. I have the same base. Both of these are a base of 3, so I don't need that base anymore. I can just say that x plus 1 is equal to 4, and that's x plus 1, not x plus 4. And then I can say that x is equal to 3. I can plug this back in to test, so if I want to check my work here, I can say 3 to the 3 plus 1 is equal to 3 to the 4th, which is equal to 81. So 3 to the 3 plus 1 is equal to 81. That checks out. So I've met my original equation. That's something you can plug in on your calculator to check as well. All right, solve an exponential equation, part 2. This is a little bit more difficult. So first thing I need to do, Google Slides only has so much of an equation editor that I can use. So I'm going to rewrite this equation the way that it would appear in your book. In your book, it would look like this. E to the negative x squared is equal to e to the x to the second power, which is equal to 1, or sorry, not equal, multiplied by 1 over e cubed. So what we're going to have to do here is we're going to have to start doing a lot of properties of exponents here. What I have to, I'm going to start off with e to the negative x squared is equal to e to the 2x times 1 over e cubed. Remember, if I raise an exponent to a power, I multiply them together. This does not become e to the x squared. I don't raise that x squared to the power. It's e to the x that has been squared. So that means I'm talking about e to the 2x. I multiply those two exponents out. Those exponent rules are found in your 5.3 part 1 notes right at the very top. Once I'm here, I can then rewrite this as e to the negative x squared is equal to e to the 2x times e to the negative 3. Again, this is another exponent property that you'll find in your 5.3 part 1 notes. I've moved this up to the numerator of my equation, so when I move it up to the numerator, I've got to turn that exponent into a negative exponent. Now that I'm here, I'm going to say e to the negative x squared is equal to e to the 2x minus 3. All right, so I've got e to the negative x squared is equal to e to the 2x minus 3. Again, that's multiplication. I've got the same base. Both of those are e. I'm multiplying e to the 2x times e to the negative 3. Since I have that same base, I can combine those exponents. The rule here is that I can say that this is e to the 2x plus negative 3, but e to the 2x plus negative 3 just simplifies down to e to the 2x minus 3. Again, that is multiplication of the same base. You will find that information in your 5.3 part 1 notes at the very beginning. Now I've got the same base and I've got everything written as one exponent. Everything here is to e. So I'm not going to say that these e's cross out, but I don't have to consider them anymore. I can just set my exponents equal to each other. So I end up, I'm going to move this over here. I'm going to say 0 is equal to x squared plus 2x minus 3. So I'm going to factor this. This is a quadratic equation. So 0 is equal to x plus 3 times x minus 1. That's how this factors out. So then I can say x is equal to negative 3 or x is equal to positive 1. If I look at this, let's go through and figure out if this works out. So we're going to do a check. First one I have is x is equal to negative 3. So I'm going to see if e to the negative 3 squared is equal to e to the 3 squared times 1 over e cubed. All right. So what I have here is e to the negative 9 is equal to e to the 6th power times 1 over e cubed, which can be written as e to the negative 9 is equal, oh, this should be e to the negative 3. That changes things. So that was e to the negative 3 up there. I forgot that. I apologize. So this should be e to the negative 6 times 1 over e cubed. This is equal to e to the negative 6 over e cubed. And then I can pull this down here because this is negative. And since it's negative and it's part of a fraction, when I pull this base and that exponent down to the denominator, that will make it a positive. So now I have e to the negative 9 is equal to 1 over e cubed times e to the 6th, which is e to the negative 9, is equal to 1 over e to the 9th, and e to the negative 9. Again, I'm going to pull this down. This is the same thing as 1 over e to the 9th. So I'm saying 1 over e to the 9th is equal to 1 over e to the 9th. That checks out. So x can, in fact, equal negative 3. Let's check out positive 1. E to the negative positive 1 squared is equal to e to the first squared times 1 over e cubed. This is going to be e to the negative 1 is equal to e squared times 1 over e cubed. E to the negative 1 is equal to e squared over e cubed. This one I'm going to do a little bit different. I'm going to pull this e cubed up top, and I'm going to call this e to the negative 1 is equal to e squared times e negative cubed. Since I have the same base here and I'm multiplying it out, I can call this e to the negative 1 is equal to e to the 2 minus 3, which means e to the negative 1 is equal to e to the negative 1. I've done all my properties of exponents to make that work out, so that means positive 1 is also going to work as well. So now by plugging these both in, I've checked my work and I've seen that these answers do work, so these are the answers to my equations. Now again, you've really got to be solid on your properties of exponents here. If we're not solid on our properties of exponents, it's going to be a struggle. Please see me with questions or concerns. If any of this didn't make sense, if working with these exponent properties don't make sense, it is something that is essential, and we've got to know how these work out in order to get these equations done. All right, last thing, you're going to get a lot of word problems in this chapter. You're going to have a couple word problems on your Chapter 5 test. You're probably going to have word problems on your quiz. These numbers, the number e especially, is used all the time in the real world. It's used in probability, it's used in radioactive dating, it's used in finance. We're going to have a whole chapter dedicated to exponential growth and decay. We're also going to have a section that's dedicated to financials and how exponential equations work in financial situations. So we're going to just go through, and this is kind of easy right now. We're just doing plug and chug. So the idea here is between 9 p.m. and 10 p.m., cars arrive at Burger King's drive-thru at a rate of 12 cars per hour. So that's 0.2 cars per minute. The following formula from statistics can be used to determine the probability that a car will arrive within t minutes of 9 p.m. F of t is equal to 1 minus e to the negative 0.2 times t. Okay, so first of all, this formula is just given to me. There's no way, shape, or form that I'm expecting you to derive this formula right now. We are not at the point in class where we're deriving our own formulas. You're going to be given a lot of formulas. This is plug and chug. This is, here is your formula. Can you take the information and then go from there? So part A is determine the probability that a car will arrive within 5 minutes of 9 p.m. So what this means is that t is going to be expressed in minutes. So I've got a work slide down here. So for part A, let me change to my work color here. Part A, I want to determine the probability. So the probability is going to be based on f of 5. Because t is going to be equal to 5, we're expressing t in terms of minutes. This is going to be 1 minus e to the negative 0.2 times 5. I'm saying within 5 minutes, what's the probability that at least one car goes through the Burger King drive-thru? So I plug it into the formula that's given to me, and I'm just going to plug this in on my calculator because I cannot do this in my head. So I'm currently plugging this in on the calculator, and I find that this is 0.632. So there's a 63.2% chance, or you could also say 0.632 probability. You can learn that in AP statistics. If you take AP statistics, that probability is reported as a decimal. So there's a 0.632 probability, or a 63.2 chance that a car will come through Burger King's drive-thru within 5 minutes. And you can stop and you can ask yourself, all right, if a car is coming through if cars are coming through at 12 cars an hour and 5 minutes pass, that's a rate of 1 car every 5 minutes, because 60 divided by 12 is 5. So that means that in theory, 1 car should be coming through every 5 minutes. So after 5 minutes have gone by, if 1 car comes through the drive-thru, that would make sense. So having a 63.2% chance or 0.632 probability of that happening makes sense. For B, it's asking what's the probability that a car arrives within 30 minutes. So this is where we're going to do f of 30, because again, these numbers for minutes are just going to go into that t. This is 1 minus e to the negative 0.2 times 30. And I'm going to plug this in on my calculator because, again, I cannot do this in my head. This is something I need a calculator for, especially when we have e. So I'll plug this in. And I will find that this is 0.9975 probability, or a 99.75% chance. And again, this makes sense. If we're expecting 12 cars within the hour, what's the probability that one car will come through in the first 30 minutes? It should be really, really high. If it doesn't come through in the first 30 minutes, that means we're expecting all 12 cars to come through 9:30 through 10 p.m., which, based on this probability here, is not out of the range of possibility. Out of 1,000 days, 25 of them, you might not have a car come through within those first 30 minutes, and all 12 cars are coming through in the last 30. But again, that's an extremely unlikely, and that's just a quick mental check you can ask yourself. Given the scenario in the question, does my answer make sense? And again, this is just plug and chug. You're not expected to be able to create this formula. The formulas will be given to you. I know that the only variable here I have is time. It's given to me as minutes. I'm making a little bit of an assumption, but you plug those minutes into t, and the book is going to make clear what is plugged into what in your word problems. So just make sure you're paying attention to those. Most of your word problems right now are plug and chug. We will get to the point where we start building our own equations, but that is going to be 5.7, 5.8. You guys have a homework assignment tonight. If you have any questions or concerns, please reach out as soon as possible, and have a great night.